Okay, so can anyone can any one of you tell me what is rotational symmetry?
Ma'am,
Yes, April.
ma'am, a square has a rotational symmetry of order 4.
Rotational symmetry of order 4. Okay. And what is rotational symmetry?
Yes, ma'am, it is rotational symmetry.
Right. Yes. So now, if I talk about rotational symmetry, I can say that when a figure is rotated around the center point, okay, it's rotated around the center point, and it still appears the same. Okay, it still appears the same as before. Okay, before the rotation, then we say that it has rotational symmetry. Okay, some examples can be equilateral triangles, squares, rectangles. Okay, then our hexagon, circle, and all that. Okay, so you can write it down with me. Said to have rotational symmetry. Now, suppose I have a square. Okay? I have a square. I rotate the square. I rotate it in this way. Okay. What happens? Again, I'll have the square. Okay. It is rotated. Now, if I rotate it again like this, okay. So what happens? Again, I'll have the same shape. Again, I'll have same shape. So this is rotational symmetry. While you are rotating it, you'll find that it will still look like what how it looked before rotation. Okay, that is rotational symmetry. You can write down the some examples.
Ma'am, I'm guessing a circle has an infinite amount of rotational symmetry, right, ma'am?
Infinite amount of rotational symmetry. Yes, Abraham, we can say that. Square, circle, regular hexagon, etc. Okay. All the regular polygons, if you see, most of the regular polygons, they also have rotational symmetry. Okay. Now, now for a figure that has rotational symmetry, there is a fixed point around which the rotation occurs. Okay, there is a fixed point around which the rotation occurs, and this point is called the center of rotation. Okay, this point is known as what? The center of rotation. All right. Shall I clear the screen?
No,
Okay.
I'm just keeping it.
Ma'am,
Okay, Manisha.
for a
Yes, yes.
hexagon or a pentagon or a dectagon, ma'am, all of the rotational symmetry is equal to the lines of symmetry, right, ma'am?
Yes. Rotational symmetry is equal to the lines of symmetry. Yes, for some polygons, it is equal. Okay. Or yes, to the lines of symmetry. Can you tell me any other figures that have rotational symmetry?
Ma'am,
A pentagon.
octagon.
Yes, pentagon, octagon. Good. Anything else? Tara, Samir.
And
Done. Okay. So let's move to the center of rotation. Now, like I said, that when we are having a figure, we have a point, okay, in it, okay, around which the rotation occurs, around which the rotation occurs. So that is known as center of rotation.
Ma'am,
Yes,
in,
Abraham.
ma'am, when you give the test of this chapter, ma'am, how will you give it?
Mhm.
Will you ask us to rotate some shapes?
Well, I ask you to rotate some shapes. I might ask you all what is the order of symmetry of square. Okay. What is the order of symmetry of an equilateral triangle? This I can ask. Then I can ask what is the center of it? What is the center of rotation? That is, you have to define center of rotation. Okay. And what is rotational symmetry? Then you can define the rotational symmetry like that. I ask. Okay. Now, there is order of rotational symmetry. Now, what is an order of rotational symmetry? So, it is the number of positions in which a figure can be rotated and still appears exactly as it did before. Okay, the number of times, the number of positions in which a figure can be rotated and it still appears exactly as it did before, that is known as order of symmetry. For example, suppose take a star, okay, a star. So imagine a star, we can rotate it 5 times along its tip and it looks the same every time, right? It looks the same every time. Hence, the order of symmetry is 5. Okay. Hope this is clear. Order of rotational symmetry. Okay. I'm going to clear the screen.
Ma'am, just a minute, please.
Okay.
Done, thank you.
Okay. I have a star. Yes.
Ma'am,
Yes.
star has order 5.
Yes, that is right, Edric. Now, when I start rotating the star, when I will rotate the star, okay, I can rotate it 5 times. Okay, 5 times it can be rotated, all right, so that it will look exactly the same as it is looking now in its original position. Okay, when I rotate it 5 times. So that means that it has the order of rotational symmetry or order of symmetry of 5. Okay, so we can write it down. The number of positions in which a figure can be rotated and still appears exactly as it is before. The rotation is called the order of symmetry.
Ma'am, order of symmetry or order of rotational symmetry?
Any you can use, okay? It's the same thing. Now, you can put down the star example. Hence, order of symmetry is 5 in the star. Okay. Now, I want you to take a minute and think about, do we have some alphabets also which have rotational symmetry? Do we have some alphabets also having rotational symmetry?
Ma'am,
Yes.
ma'am,
Yes,
O.
oh, okay.
H,
Google,
I, I,
Google Pixel. H, okay. Then
only H, I, and O.
H, I, and O. Okay. Then there are also some that when we are rotating them 100-degree clockwise, 180-degree clockwise or anti-clockwise, they appear to be same, such as the letter N. Okay, but when we are rotating it 100-degree, that is, okay, or the letter Z. Okay, and if you rotate it this way or rotate it this way, 180-degree, it will appear same. Then take a look at the letter Z, rotated 180 clockwise or anti-clockwise, it will look the same. Okay. Alright, same with S letter S also. If we rotate, it 180-degree clockwise or anti-clockwise, S also looks the same. Okay. And O is like completely rotational. Okay. Shall I clear the screen now?
Yes, ma'am.
Okay. Yes. So we talked about rotational symmetry letters. Okay. Do you want me to write it down too? Or is that okay?
What, ma'am?
Rotational symmetry letters.
Ma'am,
Could you write it down as
Yes,
well?
yes, Edric.
ma'am, a triangle has a rotational symmetry of order 3.
Yes. Angle has rotational symmetry of order 3. That's right.
Oh. Yeah.
Can you mute yourself, Patrick? Clockwise or anti-clockwise. Some of them are. Some examples are Z, H, S, N, and O. Okay. Then these letters are rotated 180 degrees. Clockwise or anti-clockwise. The letters appear to be same. Just let me know once you've written it.
Miss,
Done. Okay. All right. So let us be finished with this chapter, and I've told you all that what kind of questions may come from rotational symmetry. Okay, order of symmetry of some figures can be asked. What is rotational symmetry? Um, give any two examples of rotational symmetry letters. Okay, or draw a figure having rotational symmetry. So like that example, what is the center of rotational symmetry? Okay, questions such as these can be asked. All right. So any other doubt from this chapter, from any topic?
the I don't remember when you said the test is going to be, ma'am.
When is the test gonna be? Test will be on Tuesday. Okay, next week Tuesday. But what let me tell you the exact chapter. I think I've given you all the 15th,
When is the test
15th
for
chapter.
You given
Tuesday
14th.
next.
Ma'am, when is the test for math?
Next week, Tuesday.
Tuesday.
Yes. 14th chapter. That is circles, okay? 14th chapter test
Then
of circles on Tuesday. 15th chapter will be after it, okay? I'll let you all know about the 15th chapter. That will be later on. So I'll let you all know. From the next week, we are going to start with a new chapter in math, okay? We'll be starting with the 16th chapter, that is area of plane figure, area of plane figures. Okay, that chapter will be starting from Monday. Okay, okay, then that's all for the math class today. See you, Zara. Bye.
Bye, ma'am. Thank you.
Bye. Okay, so Samin, Abraham, Anaya, 5 minutes break you all have. Okay. you can quickly bring all the things and we'll begin the experiment. Okay.
Okay, ma'am.
Yeah.
Okay, ma'am.
Okay. Yeah. You can log out and we'll be meeting next week. Okay. Since I'm starting with the science class, we'll be meeting next week. Yeah. Okay. If you guys are ready,
Yes, sir.
okay. Can I see your can I have your videos on, please? Yes. Now, can I see the stripes that you prepared? The turmeric stripes.
Sorry.
The turmeric stripes, the litmus paper that I have explained you all to prepare. Can I see them? Okay. Yes, Abraham, I can see yours. Thank you. Yes, Abraham. All right. Simeon, yours? Filter. Thank you. All right. Yes. So now, do you all have the detergent right now?
Yes, ma'am.
Okay. Yes.
You have to make this into water, ma'am, or you have to just keep this?
Um, to mix it into water, just take a little bit on the spoon. Okay. Take a little bit in a spoon. Okay. Do it right now and put that strip into the detergent. Okay. A little part of a little corner of the strip. Okay. Around this much on the in the spoon in the in your detergent.
Ma'am, I have dry powder detergent, so we'll have to mix a little water with the detergent.
Dry powder detergent you have. Put that little bit powder on the strip and then add a drop of water. Okay, try it like that. Yes, Indian. Did it change color?
Yeah, it became much greener.
Okay. You are using the store-bought liquid, right?
I didn't hear what you said.
You're using the store-bought liquid, right?
Yeah, I'm using a universal pH indicator.
Universal pH indicator. Okay. Understood.
Ma'am, the waters become funny.
Water looks funny. Okay, it's okay. And now, the,
And is this how the detergent's supposed to look?
is this how the detergent is supposed to look? Yes, probably. Different. Can you see it's turned red?
Yes, ma'am.
Yes, very good.
Mm.
See, this
Mine
is
turned
how
green.
yours is a universal indicator, Simeon. Okay, so that is why turmeric is a natural indicator. Okay, why I asked you all to use turmeric to make the strips, to make the litmus strips, because turmeric is a natural indicator. When you use it with the bases, okay, to try out the bases, it will turn red. But when you use it to try out the acid, it will not change any color. Okay. and you're trying out with acid or a neutral solution, it is not gonna change any color. Okay. So Simeon, yours is gonna turn green, and Abraham and Anna, the turmeric strips are gonna turn red. Okay. And Anna, yours. Okay. Yes. Can you remove the blur, the background? Move it a little in the center. I cannot see. Okay, yes. Now I can see. Yes. Good. So now, well done. The first thing was a base. Okay. The detergents are basic in nature, right? Because it has your strip has turned red, means that they are basic in nature. Okay. All right. Now, um, more thing that I asked you all to bring, right? So you are having soap. Okay. Now do one thing. Wet your finger. Okay. Wet the soap a little bit. All right. Ibrahim, you're having liquid one.
Even I have liquid soap then.
Liquid soaps. Okay. Then take the liquid soaps. Okay.
We
One or
use,
two. Sorry.
we use hand wash.
Yeah, even I have hand wash soap, like liquid
A
one.
hand wash soap. Try with a hand wash soap. Okay. Let's try with a hand wash soap. So take the liquid. All right. And then put your litmus paper in it. Hand wash soap.
Okay.
Yeah. Just a little bit, like two,
We
Mine
should
one or
use a
two
color
turns
drops.
strip,
green, but
right?
it's lighter green.
Lighter green. Okay.
We should
Yes,
use
Anna.
color strip or the same strip.
No, no. A different strip.
Okay.
Okay. A fresh strip. Take a fresh strip. Nothing happened with the liquid soap.
No, ma'am, it just looked all gooey, became gooey.
Became gooey. Okay. Did you mix it with water, or you just really put the soap?
Just put the soap.
Just put the soap.
Ma'am, we have to mix it with
Okay.
water. That's why it's called liquid.
No, no, you don't have to mix it with water. Do you have the soap that we use to wash the clothes?
Yes, ma'am.
Bring it.
Okay, ma'am.
What color is the strip supposed to turn after you apply the soap?
After you apply a soap, it is supposed to turn red. One second.
Ma'am, what do I do with
Yes,
the
Abraham.
soap now? Do I throw it out?
Um, you have the soap that we use to wash the clothes.
No,
Okay,
ma'am.
so again,
I'm just getting that.
getting that. Okay, bring it. All right, wet your finger, put it on the soap like this, and then with that finger, put that on the strip, on the little part of the strip.
Okay, just give me a minute. I'll also bring that soap. I tried using liquid soap, but it
Yeah. Shamin, you were saying something? You muted.
Ma'am, I was not able to get any soap, but I was able to make it into a liquid, and it didn't come gooey, but it didn't even change color.
It didn't even change color, or it did change color?
It didn't, ma'am, and I could not have the other one. I could not have the other soap. The one you're talking about is because this soap has run out in our house.
Okay, no problem. When you'll have it restocked, that time you can try. Okay. Yes, Anaya. Um, 1 second. Okay, I can see yours. Very good. So with this soap horse has turned red. Good. Simeon, yours?
Turned green.
Turned green. Okay, with the soap. All right. Okay. So since now we are going to check out the
Oh, look at the
acid.
density.
Yes. Yes, Abraham, I can see that. Right. So what we are going to do next is that yes. Mm, have you all got the lemon juice? Means a piece of lemon.
I have a piece of lemon.
A piece of lemon. Okay. So what we'll do now, take your strip, put it like this, okay? Squeeze the lemon juice on the strip. Take a fresh strip again, okay? A fresh strip and squeeze the lemon juice on the strip.
Oh, can I squeeze it in a cup and then pour the cup, then put the thing in the cup, the strip in the cup?
Yes, yes, Abraham, you can do that. Yes, Simeon, yours turned red now. Yes. So that means, Simeon, since you're using a universal indicator, this is acidic in nature. Okay, lemon juice is highly acidic in nature. See, can you see the universal pH paper? Okay, this is
I
a
have a
chart
pH scale set, and it's
in the set.
according to that scale, the lemon juice is pH is 3.
pH is 3. Yes, that's correct, Abraham. That's correct, Simeon. Okay, so lemon juice pH is 3, and your paper will turn red. But Abraham and I, the turmeric strips will show no color change. Okay, Abraham, did it change?
Ma'am, it changed into like no color.
No color. So the turmeric is not going to like change the strip color. Okay, that means either the substance is neutral or the substance is acidic in nature. Okay? Can anyone tell me what kind of acid does lemon has?
Amino acid.
Amino acid. Okay. Anyone else?
Citric acid.
Citric acid. Okay. Anaya. Okay. Yes. So that is right. Simeon, lemons have citric acid. Okay. Abraham, the lemon has citric acid. All right. Now,
Now,
one
what
more
color
thing.
was it supposed to turn?
Right?
What color was it supposed to turn? It was supposed to show no color change.
Yeah, I didn't
Okay.
show any color change.
Yes, it won't show any color change. Now do one thing. Take the first strip that turned red. Okay. Once again. Take the
The
first strip that
detergent one.
yes, the detergent one. Now put it again in the lemon juice. Okay, put it in the lemon juice. It will again turn yellow. So that Abraham. So that put it in lemon juice and show.
Ma'am, I put it in lemon juice and then I put it back in detergent. I put it back in lemon
Yes,
juice.
I saw that.
Now it turned back to its original color.
Yes, it turns back to its original color. So now that is when you turned it, when you, yes, Abraham, I can see. When you had put in it in the detergent, it turned red. Okay, because it is basic. When you put the basic again in the acidic, that is the lemon, okay, it will come back to its original form. Okay, so that is one thing. Now we are going to test it out again with one more thing. Okay, take a fresh strip.
Ma'am, is that,
Yes, Abraham.
ma'am, are we now, we can reuse the litmus paper strip, right, ma'am?
Um, okay, try reusing it. Okay, or try out with a fresh one.
Ma'am, I tried putting in the detergent, it turned red back again.
Yes, it will turn red back again. Yes, Simran. What happened when you put it in this thing? Can you show once again?
In what?
In in milk,
A fresh one, right, ma'am?
a fresh one. Yes. First try out with a fresh one in milk,
It turned sort of a very light green.
very light green. Okay.
No, actually, it turned yellow. Sort of a yellowish green.
Okay. Check out in your pH scale, Abraham. It's going to have no color change with milk. Okay. No color
It didn't
change
have
with
any
milk.
color change, ma'am.
Yes, that's right. Exactly. You won't have any color change when you're doing it with milk. Why? Because milk is again acidic. Now, who's gonna tell me what kind of acid does milk has?
I don't think it has any acid.
I think it has hemoglobin, but that's not an acid.
Okay, so I'll tell you that the milk is slightly acidic in nature. Okay, not highly acidic, not very acidic, slightly acidic in nature. Why? Because it has lactic acid. Okay, it has lactic acid. So
On
it's
the
slightly acidic in
on the
nature.
pH scale in my indicator, it's showing the pH as 7, which is completely pure.
pH has 7, which is completely pure. Okay, but in real, like that is it has slightly, very slightly acidic in nature. You could see while you were on the your stripe that your universal indicator that it has a very light yellowish green note. It showed very light. Yes. So that is it has a very light. It is slightly, very slightly acidic. Okay, that is the thing. All right. So we tested it with two acidic, two basic substances. Okay, Simeon, yours is the universal indicator. Now, directly put it in water, not anything mixed with it. Only water.
Fresh one, right, ma'am?
Yes, a fresh one.
It turned the exact same green as the milk.
Then it turned the exact same green as the milk. Okay, means that your water is very slightly acidic, but water is the property, the major property of it is that it is neutral in nature. Okay,
So
water
in this, it's showing pH is 7.
neutral. Yes,
Yes.
water is neutral in nature. Okay, but there are things added to the water that can make it acidic. All right, the water's original property is not acidic, but if we add something to it, okay, some acid or something, it makes it acidic. All right.
Have any
What
color
about the
change, ma'am, in the
filter?
water?
You didn't have any color. Yes, Abraham and Nana, you won't have any color change in water. Okay, why? Because it is neutral in nature. The water is neutral in nature. It's not acidic or basic. All right. So this was one way. Like we have seen, we've done the litmus test now, and there is another way where you make the litmus papers. Have you ever seen like a purple cabbage?
A purple
Purple
what?
cabbage. Cabbage. Yes. So with that purple cabbage also, a litmus paper can be made. Also, it can be made with the hibiscus flower. Okay, the purple strips of litmus can be made with hibiscus flower. Why I'm telling you all this? When we were doing the chapter on acids and bases, we talked about the natural indicators. Right? We talked about the natural indicators. So in the natural indicators, again, the hibiscus flower is also a natural indicator. Okay, the hibiscus flower is also a natural indicator. So all these things will indicate whether a substance is acid or base. Okay, even the purple cabbage and all, they will indicate if the substance is acid or base. Okay, how do they make it with a this hibiscus flower or the purple cabbage? They take it, you take the sheet, you rub it on the sheet, okay, until it gets colored, it gets purple colored. You rub it in the sheet. So that way, the indicators from that is also prepared. But we use the turmeric indicator. Okay, why? Because turmeric is easily available, and turmeric is also a natural indicator. So we use the turmeric powder. Yes, Simeon.
I just tried smelling it, each one, and like the one I put in soap, the soap smells like soap, but the one I put in soap does not smell like soap. It smells
What
different,
does
like
it
a
smell like?
weird, stinky smell.
Weird stinky smell. That's maybe because you mixed this thing, the turmeric, right, with the soap. Abraham is smelling.
Ma'am, I can't smell anything.
But each strip
Anything.
smells different.
Each strip smells different. Yes, that is possible. Okay, because of the haldi and the your soaps and your detergents. Okay, that is possible that it may smell different or it may not
But it
smell at
doesn't
all.
even smell
That
like
is
the
also
thing I put it in, even after that.
okay. All right. So that's all with the experiment. And now can I have your exam, please? Can I have your exam, please? Yes. So I'm going to take one picture with it. Can you hold your strips or your glasses or something up? Okay. And Abraham, you to do back the position you were having, okay? Like along with your go back to the position. Yes, that is good. Can you Anand, can you hold your strip? Yes, sure.
Ma'am, is like this okay?
Yes, this is okay, Abraham. We can see your strips, we can see you. So this is okay. All right. Now, ready? Okay, yes. Okay. Very good. All right. So now we'll be meeting again on Monday. I'll be checking your papers this weekend. Okay, we'll discuss the exam of the 15th chapter of science. All right. And then after that, what are we going to do? Yes, we can do another experiment. Okay, we can plan another experiment. We will revise the three chapters for the upcoming test. Okay, I wanted to ask you all, how much time do you all think you guys need for the preparation of three chapters? Is next week Friday okay? 1 week, or after the next week, the like week after the next week, Tuesday, it will be.
Week after the next week.
Ma'am, week after the next week, Friday.
Friday. That is a lot of time, Abraham. That is
No, I
quite
think
a
week after the next week, Tuesday, ma'am.
Tuesday. They are simple chapters, don't worry. One chapter so you all have prepared already with the disaster and everything. It's simple. So don't worry. Okay, I'll give you all time. Week after the next week, Tuesday, okay? I haven't announced the date because I wanted to confirm with you all that that much time for the preparation is okay. Okay. Also, one thing I wanted to announce this in the math class, but since I have forgotten, um, can we like this is for since we are operating the NXT classes accounts on different social media platforms. Okay, is it all right if we can post your some of your pictures, such as doing experiments and things, okay, on the on those platforms, okay? Take permission from your parents, okay? You can ask your parents if that is okay, all right? And you all can tell me in the next class, all right? If it's okay. Like while conducting some activities, I also took some pictures while conducting this thing. The last teach back session. Okay, so if it's okay, like if we can compile a video of that and share it on the social media platforms. Okay, so that others can get to know about it. All right. So ask permission. All right. If it's okay with them, if it's okay with you, then only we are going to post it. Okay. So that was it. All right. So hope you all enjoyed.
Question. Can I send a picture of my experiment on the group?
Yes, yes, Abraham, definitely. In fact, all three of you can organize, assemble the things together at one place. Okay. Put the strips near it. You can click picture and post it in the group. Send it in the group. That's totally fine. Okay. No problem.
Do we have to do it?
Do you have to do it? If you want, you can do it. Okay. If you want, you can do it. All right. Okay. Okay, then. Hope today was fun. The experimentation. Hope you all enjoyed doing it. Okay. That's great. Good to know. Okay, then we'll be meeting now on Monday. Bye. Same timing, okay, for the classes.
Ma'am, thank you, ma'am. Bye, ma'am. Bye, Sanyan. Ma'am, is there English class today? No, right?
No, no. Monday.
Okay, ma'am.
Okay.
Bye. Thank you.
Bye,
Bye.
bye.